we're going to go through 3 examples here of a little bit different types of two-step equations, not so common. We've gone over a couple examples already of the normal two-step equation, but let's look at these 3 different ones. So the first one here is a two-step equation with a division in it. You see here that this variable term in this equation right here is not a multiplication like most of the time. Instead, it's a division, d divided by 4. Well, the rules are the same here, that we cannot do anything to that variable term until it is by itself. So that means I need to get rid of this minus 3 that's on the left side of the equation here. I'll balance here. And to get rid of a minus 3, I'm going to add 3 to both sides. If I add 3 to both sides, this side leaves me with d divided by 4. Negative 3 plus 3 is 0. This side, 6 plus 3 equals 9. So d divided by 4 equals 9. Now our next step then is to undo the division here, this d divided by 4. We're going to undo that division by multiplying both sides by 4. Multiplying both sides of the equation by 4. And here, this is really 4 over 1, right? So 4 and 4, they cancel each other out, leaving me with d. And over here, 9 times 4 equals 36. So it looks to me like 36 is the number, the solution here, the number that if I put into the original equation, will make that equation true. So let's do the check here. And we will start with the original equation, except instead of d, I am going to put in a 36. 36 divided by 4 minus 3 might equal 6. We'll see if this comes out to be true. And we use the order of operations in the check. So 36 divided by 4 goes first because divisions are done before subtractions and additions. That's 9. So 9 minus 3. 9 minus 3. Does that equal 6? Yes, it does. Both sides here are equal, which means my solution is correct. And the answer is D equals 36. All right, let's take a look at our next equation. This one has a negative number that is added on to the variable term. So again, the variable term is the one that we cannot change until, we can't do anything to that until it is by itself. Here's our equal sign balance line. And so what our goal is always in solving equations to get the variable by itself. And so that means I need to get rid of this minus 5. Well, how do I make negative 5 go to 0? You might be tempted to subtract 5 because there's a plus here. But if you just subtracted 5 from negative 5, you wouldn't get 0. You would get negative 10. So in order to make this negative 5 go to 0, we can think of it as subtracting negative 5, taking away negative 5 from this side of the equation. But remember, sorry about that. Oh gosh, that's awful. But remember that subtracting negative 5, that's the same as adding 5, because this is really a keep, change. Subtracting a negative, taking away negative, same as adding. So on this side of the equation, I could just say plus 5. Over here, this goes to 0, leaving me with 3n, my equal bar here, leaving me with 3n, and 3n is equal to 7 plus 5, which is 12. So 3n equals 12. Now I'm left with a multiplication equation. We undo this multiplication by dividing. So we do it on one side, we do it on the other side. 3 divided by 3 is 1, and we are left with n equals 4. So I think that's our solution for this one. Let's go ahead and do the check. So again, in the check, we take our original equation, which is negative 5 plus 3 times n, and I think that n is equal to 4. I think it's equal to 4. That's what I got for my solution over here. So I'm going to put in a 4 here. And now let's go ahead and use the order of operations again. So don't get messed up here where you might think, oh, I'm going to, do negative 5 plus 3 because it comes first. But that's not the order of operations. The order of operations is to do multiplication first. So it's negative 5 plus 12. And we'll see if, does that equal negative 5 plus 12? Yep, that's 7. So my answer is correct, and I'm happy with n equals 4. All right, one more type of example. I call this one the twisted equation because it really, it's tempting when you see this because there's a subtraction here. It is tempting to want to add 3 to get the variable term by itself. But I will tell you that the first thing that you need to do in these problems where you have a negative sign in front of a variable is same, change, change. Keep change, change. We need to change this subtraction. Change that to plus and the number after it to its negative. This equation now at 3 plus negative 2n equals 13. Now you're seeing that it's an addition equation, and what I need to do is I need to get rid of this plus 3. I can put my circle now around this negative 2n, not around 2n, but around negative 2n. And that shows me very clearly then here that I need to subtract 3 from both sides. The minus sign is still there now, and this is the most common mistake with this, is that that minus sign in front of the 2 gets dropped, and you end up with the wrong answer. Okay, so negative 2n equals 13 minus 3, that equals 10. Okay, and then we'll divide to undo this multiplication, divide both sides by negative 2, and n equals negative 5. Okay, so I think that's my solution. Let's go ahead and do the check here to see if I did it correctly. So we'll start with the original equation, 3 minus 2 times n might equal 13. Notice I didn't put the n in there. Instead, I'm going to substitute in my solution, which I think is negative 5. And I'm going to use the order of operations again, PEMDAS. Use the order of operations in the check, okay, always. And so that means 2 times negative 5 goes first, so that's 3 minus negative 10. 3 minus negative 10. And 3 minus negative 10 is 13. So